Thank you for joining me, Glenn. It's an honor actually because I've been following you for a long time, and it's been great to learn from you on YouTube and from your postings there and the videos and everything. And it's finally awesome to have you here, and we can ask some questions. But feel free to not feel constrained by the questions, because it's supposed to be just like an open conversation. So we'll take it very leisurely like that. I want to introduce you by saying that you have what's called a Smart Energy Lab, which is basically a place where you test equipment, but you also have an installer background. Is that correct?
Yes, I've been an installer. Well, I did my first system in 1991, so maybe 30-something years now.
That's incredible, yeah. And then are you continuing your installations now, or are you only testing and stuff like that?
Pretty much. The only installation is done here at the lab. In fact, I've got 2 electricians on staff who do the installations for me. I'm just really supervising them. And the installations are for training, demonstration, for product content that I create for my YouTube channel. That's kind of the level of installation. There's a little bit that goes on around the co-op where I live. So I'm not sure if you're aware of this, but I live on an off-grid co-op community. And look, I'll show you a picture of it. Hang on, here we go. That's it there. So that's Mount Tulibawong. My house is the one in the sunshine, actually. It's just good timing when I took that picture from my drone. It's a straw bale house. There's 70 people live here. It's been off-grid since 1974. There's 30 homes. And what you see in this picture is one cluster of 7 homes, which are all interconnected with a microgrid. So we run a small microgrid. We have about 110 kilowatts of solar. Most of that's tracking solar in a paddock. And all the houses have their own standalone systems. They have batteries, solar, and inverters, but they have a microgrid instead of a generator to back them up.
Ah, okay, that's very interesting. And that was actually going to be my first question. You have pretty much lived through the development of off-grid as a technology. And do you think now that when you look back on the history of off-grid, sort of, can you make some thoughts about that, like the history of off-grid in itself? Like, how does it look now compared to where you started? It's probably enormous difference, obviously.
That's a great question. I really wish I'd taken some photos of my first system in 1991. It was fairly typical of off-gridders in Australia. It was very DIY. It was cobbled together with second-hand components like second-hand batteries from a telecom facility. Solar panels cost $15 a watt back then, so we had 3 75-watt panels perched on a frame up on the roof, and we had 1 2 kilowatt, well, necessarily one kilowatt square wave inverter, which was absolutely terrible for motors. Like, they'd overheat and they'd make horrible noises and eventually fail. So that's where I started in 1991. But actually, off-grid in Australia's got a long history, way back into the 70s, mostly remote area and telco sites. So off-grid at Murumura, where I live, started in 1974. People had virtually no solar. It was gas and wood heating, and gas cooking, even gas lighting and candles. And a few people put in very, very small solar systems, literally a solar panel lying in the paddock with a bit of wire going back to the house to a battery that ran their lights. And so in the ensuing 30 years or so, we've seen a revolution in what off-grid means. I'd say in Australia, off-grid now is what you would expect on-grid, but maybe a little bit more efficient, or a lot more efficient.
And then it's interesting what you're describing, because in the start, when we started up here, the company and doing solar, we traveled around a little bit to see how Thais were using solar. And that is actually how Thais are using solar right now. Like, for the poor Thais that don't have a lot of resources, they can't go to an installation company. They will do DIY themselves. They will use equipment that they have. They will use the car batteries lying around, stuff like that. And it's off-grid systems that they just connect up and use for the TV and use for some lights. And even though it's so small, it's able to help them a lot in daily life because their income is so low. So it's actually very good.
Yeah, look, I mean, it's not a fair comparison, Australia to Thailand, in terms of systems because of the different levels of income. But what solar has meant for many developing nations is pollution-free lighting, because a lot of countries still would burn kerosene or candles indoors, and the indoor pollution levels are pretty terrible. But it doesn't take much to build a lighting system, an old car battery, one panel, and an LED light, and you've got lighting.
Exactly. And what an enormous change that is. But of course, Thailand now, we have those poor areas, of course, but we have a lot of affluent Thais, and we have a middle class, and we also have a huge expat community. I don't have an exact number, but you're talking about tens of thousands of expats that live here, and they are the people that we normally install for. So we install modern systems, just like you would install, on-grid hybrid systems with LFP batteries and so forth. But there is also that community of the Thais where they share information about DIY and those cheap systems and inverters that at least in the past tended to break down extremely fast, but because they were so cheap, they were able to buy new ones. But of course, and that brings me to the next question about the off-grid technology, like how much it has improved and stabilized. Like in the past, the inverters would break down a lot more often, but now it seems like the technology is stabilizing and able to bring forth off-grid inverters that actually don't break down as much.
Yeah, there's quite a lot of reasons for that. I mean, experience. So companies have learned how to make more robust products. The power ratings of components has improved a lot. I remember my first inverter, actually I made it myself, used 2N3055 transistors as the output circuit. As soon as I put an inductive load on it, they blew up because they couldn't switch fast enough, and therefore overcurrent would kill them. But now we have high-speed switching electronics at very low cost, and also the microprocessors inside inverters can limit current very, very quickly. Not within not a cycle, but within fractions of a cycle. So if you get a transient, like a sudden change in power level, the inverter can protect itself from overload. So yeah, I often say these days you can't kill an inverter by short-circuiting the output. It'll just shut down.
Yeah, we have all the overload protection stuff. But that brings me to the next question, which is more like, how do you use off-grid to the best, in the best way? And what advice can you give to consumers? What is the most important thing when you are planning to run an off-grid system?
Yeah, I always start with loads. It really is, you're building a power system, an off-grid power system to run some loads. The loads determine everything. So if you start with looking at what resources you have for energy around you that aren't electrical, that may be renewable and may be lower cost. So it might be passive solar design. So buildings that heat and cool themselves well without any energy input. Then things like cheap sources of energy. It could be biogas from waste composted to make methane. It could be wood, if you have a renewable source of wood available. I mean, wood actually is amazingly energy dense. So Australian hardwood is 4 kilowatt hours per kilo of energy. It's more than a battery. So look for those opportunities. Then when it comes to renewable energy, think about the different types. You've of course got wind, you've got water, and you've got solar. You could say biogas as well, is renewable. But wind, water, and solar, look at what's available to the consumer. Now, in Australia, a lot of places started off in the 70s using wind because wind was actually more cost effective than solar. But solar has really taken over almost completely as the first choice for off-gridders. But you may actually have an excellent site. You might have, for instance, a creek with a relatively small amount of fall, 10 meters or so across the property or even more. And that is the cheapest form of renewable energy, is microhydro. We have a small microhydro system here at the co-op. It falls 90 meters in height difference over about 700 meters of pipe run. And it just runs, beautifully for like 12 years. I think we've replaced a $10 bearing over 12 years. So it's very low tech, very easy to maintain, virtually no electronics other than motor windings, and some way of regulating the charge of the batteries.
Okay, so first advice then is when you brainstorm how to have electricity in an off-grid situation, look for other sources, not only solar. Okay, that's great. And then what I usually say when people come to me and look for off-grid advice, I say that number one is we have to oversize everything. Do you think that's a good advice?
Well, maybe I'd start with undersize your loads. So like use efficient appliances. It's not necessarily undersizing, that's probably the wrong way of putting it, but choose efficient appliances. Like don't use incandescent lighting because it's really a heat source with a bit of light. Use LED lighting. It's very efficient for the amount of electricity it consumes. So there's one example. The same can be applied to loads like refrigerators. It might cost a bit more for efficient refrigerator, but it'll save so much on energy that the cost of a solar system to power it is greatly reduced.
And you don't have these big peaks that will overload the system and all that. So absolutely. So then when we talk about appliances, efficiency of appliances, and insulation, and then we're over to house design, like what kind of windows you have, what kind of walls, all of that. And you also have been incorporating that in the community that you live in. Is that correct?
You could say we're an experiment in alternative building over 40 years, 50 years now, nearly. 47 years. The early places were built very primitively. I often refer to them as hippie built. People would just cut down some trees and get some old tin and make a shack, and then they'd try to make it more comfortable. It wasn't actually designed very well to start with. Then people started using materials like mud bricks, which for this climate aren't that good. You think like a solid mud brick, which is 250 mils thick, would be a good protection from the cold. But our climate here in wintertime is continuously cold. And so the cold seeps through the brick. And so it just doesn't actually work that well. Then people started doing poured earth, which is a very, very thick earth wall stabilized with cement that worked better than bricks because of its thickness. And then more lately, straw bales, which sounds like some sort of children's story, a straw house, but it actually looks pretty much like a earth-built house because it's rendered in earth on the outside and inside, and the straw is completely encased. So for our climate, and I must emphasize considering Thailand has got the opposite, straw bale works really well. But in temperate climates, in tropical climates, you most likely want lots of natural ventilation, shade from the sun, and not a lot of thermal mass. You don't want stuff that heats up and stays hot all night long.
Mm-hmm. Exactly. So it's all about planning on different levels to make so that the load on the solar to cool that in Thailand to cool the house down is as little as possible. Basically, that's the goal there. And then if we end the off-grid discussion, we have to move on to on-grid. So we have some time for on-grid and hybrid also. But I'll leave that open to you. Is there anything else that you want to mention for people that are interested in off-grid? What's the most important thing they can do?
Well, like I said, it does start with the loads, and you need to, certainly as an installer, understand what the customer's objective is. And sometimes their objective doesn't meet their budget. So, being aware of their financial limitations around their expectation versus what their budget can achieve. So, I actually had a customer who had a health condition which meant they had to have 24/7 air conditioning, and they wanted to have an off-grid house, and the energy consumption of that was going to be tremendous. So it actually wasn't viable for them to live off-grid because of their health condition. You also have to consider how long you're going to live there and are you going to age in that property. So things like you might be young and fit and quite happy chopping lots of wood and, carting water, but as you get older, it's not so easy. So sometimes planning for change. And on the low end, like small people, children, planning for growth because they have to use energy as they grow. So, there's a bunch of factors that you have to get from the customer to come up with a design that sort of meets their expectations.
Yeah. Now, when I talk to customers, that's where the problem most often comes. It's the budget because off-grid if you want to do that properly with LFP batteries, and it gets expensive. It does, so that's where it most often stops.
Yeah,
Yeah.
I often start with, have you had a quote for connecting to the grid, just to see what you're competing with? Because if the quote for connect to the grid is $100,000, you go, well, we can do something for you much cheaper than that.
Yeah. Exactly. Good point. Okay, let's talk about the grid in Thailand a little bit. Let me describe the situation, because the grid in Thailand is notoriously bad. It's a lot of brownouts, it's a lot of bad voltage, but it's also sometimes frequency problems. And for example, some manufacturers rate the Thailand grid as the third worst in this area in Southeast Asia. So we do have problems with it. Not in all areas, but it's certainly something both the consumer and installation companies has to be very aware of and prepare for. What's your grid like in Australia? Do you sometimes meet bad grid, or is it very good all over now?
Well, it's a big country, and we sort of have one main eastern grid called the NEM, the National Electricity Market, that spans from Queensland to South Australia. So something like from end to end, 4,000 kilometres, I think. It's actually one of the biggest interconnected grids in the world. Then we've got the Western Australia, where we've got the Northwest Interconnect, Southwest Interconnect. So there's sort of island grids that also form, larger collections of generation and storage and consumers, but not really massive. So those are very interesting now, because what some of the utilities are doing is realizing that rather than trying to support hundreds of people on a very dispersed island grid, they're giving them individual standalone power systems which are owned by the utility and billed by the utility, because it's cheaper than maintaining their infrastructure, their transmission lines over hundreds of kilometres of desert.
Oh, that's very interesting. I don't know if that will ever happen in Thailand. Okay, let's go on to how to handle bad grid. Once you have a bad grid, you maybe have bad voltage. What is a good way to approach that situation?
Well, this is when hybrid inverters come in very useful. They can disconnect from the grid and continue to run loads, or at least some of the loads in a house, and the term is when the grid is dirty, meaning the power quality is poor, voltage is high or low, frequency is high or low, all completely blacked out. And so having a hybrid inverter between you and a dirty grid can protect your appliances, can protect your business from being shut down by going offline for a while, and can also benefit the grid by reducing some of the load on it when the sun's shining on your battery systems supporting it.
And specifically about brownouts, do you see differences between hybrid inverters, and are there hybrid systems that are better at handling things like that than others?
Definitely, there's a quality range. In fact, some of the best hybrid inverters are ones which have been built for off-grid, but can also be used on-grid because they have high surge load capacities. They can handle 2 or 3 times their rated power for a few seconds, to especially for motor starts like pumps and fans and air conditioners. When they start up, they have a high inrush current. And so they make an excellent hybrid inverter because of that really big surge load design. But also they tend to be bigger, so their capacity to run without the grid. So most of the hybrid systems here in Australia generally only have about 2.5 to 5 kilowatts of backup capability, which might sound a lot, but really that's 2 kettles. So the larger ones, which come from more of an off-grid base but have been certified for use on grid as well, often have ratings from 7 to 20 kilowatts.
Okay, let's talk about EV a little bit. Okay, we're moving through topics quite fast here, but we can also go back, no problem. But let's talk about EV, because we get a lot of questions on Facebook and the groups we have about how solar can be combined with charging of electric vehicles coming, and this is probably something that we're all going to face more and more. And one of the things that I say is that you don't really want a charger that is charging very fast. It has to be a relationship between how much energy the solar system can output and how big a charger that you should have if you want the charging to come mainly from the solar system. And there's a lot of lack of knowledge in these terms. So what's your approach there? What can you guide us in how to think about EVs and how to combine it with solar in the best possible way?
Yeah, well, we've got, I think, 7 EVs here now at the community. It's amazing how quickly that's happened. And we've got different charging systems. We've got most EVs come with a plug-in charger, just to plug into your normal domestic power point. And most of them have settings for rate of charge. You know, it might say 6 amp, 8 amp, 10 amp. Therefore, you can choose a lower rate of charge if your solar output's quite low. You want to try and take a longer time, as you just pointed out, to charge the car, to maximize the solar component of the charging of the vehicle. We've also got the type 2 outputs and type 1 outputs for faster AC charging, typically 3 to 11 kilowatts, 3-phase, and then we've got a 50 kilowatt DC charger, which we only really use when the sun's shining, because we need that full power of the solar array, because we're completely off grid here. So we need our solar trackers really putting out lots of power, and then we can charge the cars in less than an hour from nearly empty. So that's good. But there is a better solution to maximizing solar when charging EVs, and that's smart chargers. Smart EV chargers are ones that can do a variable rate of charge based on the amount of surplus solar energy you have. So they measure the exchange with the grid. So they have a CT, a current transformer, on the main conductor or conductors going to the grid. And they have a CT that measures the production of your solar system. And whenever the production of the solar system is too small and you're starting to import power from the grid, then they'll reduce the charge rate on the car. Because most cars, well, all cars, electric vehicles, have an inbuilt charger. The charger isn't the thing on the wall, it's the thing in the car. You're just supplying AC power to the car. But they also have communication pins, which the car can talk to the supply equipment, and there's ability to control rates of charge. I mean, it's all about looking after the batteries. So basically the car's looking after its batteries, their thermal condition, their age, etc., and adjusting charging to suit. But that's where smart chargers can really help.
And are the manufacturers of the EVs, are they also providing smart chargers now, or is that third-party chargers mostly?
I don't know of any car manufacturers supplying smart chargers yet. I'm sure it'll come. It's interesting that Tesla just announced that you're not going to even get a plug-in charger with your new Teslas. You're going to have to buy your own charger.
Okay, but that's very interesting. I mean, that sounds like a great solution for combining solar, those smart chargers. That sounds like the future there. But that also brings up another topic, and that's when an area of technology is developing so fast as EV technology right now, I often say to customers that you might want to hold back a little bit, because it's actually changing every year right now with new technology and battery sizes and the car technology. So when the technology is changing so fast that what you buy today might be seen as old in 1 year from now, then it might be a good place to actually hold back a year or two and to see a plateau, so that the technology slows down, the changes slow down a little bit. What do you think about that?
Well, it's easier in retrospect to see those plateaus. It's hard to predict them. It's also cost driven too. So, with the rapid increase in fuel prices recently, we've seen in Australia a sudden increase in EV sales, just because people are feeling a shock at the petrol pump and responding by buying an electric vehicle. So it's not always logical financial decisions. It's often emotional, which is I don't want to be beholden to the price of petrol. I want to have a vehicle who's got a fairly reliable cost of running. And if you've got renewable energy, it's also guilt-free driving. I mean, I live on top of a mountain. Me and my partner often do, 3-4 trips, which is about 40 kilometers each time up and down the mountain to collect kids, take them to sport, take them to work. And if we were running on an internal combustion engine, it would always be a little bit, I don't really want to make this trip because I'm wasting fuel. It's costing me money. But with free solar and electric vehicles, it's really maybe a little bit of wear and tear on the vehicle and some of your own time, but it's relatively guilt-free.
Yeah. Well, that's a good point. But at least if you are going to buy an EV now, don't expect that to be the end of that technology. It's like I think for many years we're still going to see enormous development in battery size and how the cars are going to work and charging. And for example, like you mentioned, DC charging at home, which not long time ago nobody was even thinking about that. Can you explain how that can work with a solar system?
Yeah, so like I mentioned before, when people say an EV charger at home, they generally mean either a plug-in piece of equipment or something that sits on the wall that they plug into their car, but it's actually just an AC supply to the vehicle, and the vehicle has a AC to DC converter built in because batteries are always DC, so they've got to be charged with DC. But depending on the type and the age of your vehicle, you might have a Type 2, a CHAdeMO DC port, and that means you can directly charge the car with DC power. Now, the advantage of that is generally you can charge it faster, a lot faster. We're talking now, 350 kilowatt DC chargers. It's insanely fast. 10 minutes, your car's full. But for domestic, they're now making small DC chargers. I've just had an interview with Delta Electronics, and they were talking about their 25 kilowatt DC charger, their 11 kilowatt DC charger. And generally these are 3-phase, though they do make single phase as well. And now you're charging the vehicle at a rate that you choose, not what the inbuilt charger of the car is.
So that's the future for sure, and that's one example where there's enormous development. So that's great, and I think EVs is just going to get better and better. So I'm looking forward for my next car. I hope it's going to be an EV for sure.
Once you've driven one, you can't go back to. Just the silence, the smoothness, the acceleration, all of it is just so much better.
Exactly. Sure. Okay, let's move on to, we are living in a culture where a lot of concepts regarding solar systems is not yet quite in the culture. I'm thinking of concepts like kilowatt hour, which is key to understand solar systems and to understand EVs. Do you have any thinking about that regarding how we can sort of help our cultures to understand these concepts better?
Well, let's take EVs for an example. Even though you'll find somewhere on the data sheet the kilowatt hour capacity of the battery, generally the customer is concerned about the range of the vehicle. And so using another metric to give an indication of the usefulness of that battery. So just telling someone they've got a 64 kilowatt hour battery is pretty useless unless they know the kilowatt hours per 100 kilometers for that vehicle, etc. But to say, well, the test reports say, according to the EPA, this has a 500 kilometer range, that's the information they need. So in a way, I don't think it's that important to convince people they need to understand engineering terms. It's just got to be relevant to their skill and need.
Okay, that's a good point. Obviously, that it might. Yeah, sometimes we can translate the concepts and the words that we are using into relatable terms. Yeah, good point.
I'll give you another example too, which is from Outback Australia. So we had a organisation here called the Centre for Appropriate or Alternative Technology, CAT, I think they're called, and that was partly government funded, and they provided power systems for remote Aboriginal communities in Australia. And these would be in very isolated areas. And often the people who had these systems had a poor understanding of how they worked. That's not a criticism, it's just a fact. So they designed them with a monitoring system along the lines of a vehicle's dashboard. Instead of having a voltmeter for the batteries, it was like a speedo. And sorry, not an amp meter. You had amp meter was set up like a speedo. You could see how fast you're driving your power system. The more amps, the more it would rotate to the right. And in terms of how much was in your batteries, they had like a fuel gauge showing full and empty. And that was the level of information that was appropriate for those customers.
Yes, and that also lies with the manufacturers of the EVs, that they have to adapt all the interfaces so to make it sensible, to make it more intuitive for the consumer. So that's, but I give you an example from solar work that you probably have heard a million times. Like I want to have a UPS that can run 2 air conditions, my TV, my internet. And so a lot of the information that you get from a client is very unspecific. It's very, you can have an air condition that takes 5,000 watts and you can have one that only takes 500. So it makes, how do you deal with that?
Yeah, good one. You can help explain the problem, which is use an analogy. For instance, if you ask me what car should I buy, the next question is, well, what are you going to do with it? Are you going to put 20 people in it or 10 people? Are you going to drive long distances? Are you going to go off-road? So we need to know more about those appliances so that we can better design a system for your needs. I usually ask customers to fill out a load sheet, which I might have a list of rooms in the house, for instance, and just list what appliances they have in those rooms, and then make a guess at the hours of operation. And if they have any knowledge of the power ratings of those appliances, write them down as well. I mean, if you're doing a home visit, this would be a very good activity to go through, is actually just do this as a service, provide a really detailed load sheet. But it might be a new build, so there's nothing there already. So you'd have to, construct a load sheet out of what they imagine they're going to need. And from that, you can calculate the amount of energy that they need on a daily basis. And from that, you can cost and build the system.
Now, we actually, on the service that we do, we actually sometimes just take an amp meter and measure it because sometimes the specifications are not correct. And, if especially with air conditions, you really need to know by their direct measurements. Do you agree with that, or do you think you can go with the specifications more? Or
I'm sorry, I'm just grabbing something. This is kind of relevant. I've got a power meter here, which is extremely useful for doing home energy assessments. I'll see if I can just bring it up on my camera. Hang on. Here we go. So here it is. Oh, zoomed out too much. So I don't know if you're familiar with, this is an Australian product. There's many similar ones around the world. This one's called a PowerMate. It's measuring the power at the moment of whatever I plug into it. So on the end of a cord, so it's got a cord here, is a piggyback plug. That means you can plug an appliance into the back of the plug and then plug the plug into the wall. And so it's measuring whatever you plugged in. It also measures cost. And so you can set a cost for electricity, and it can calculate, for instance, per year, whatever I plugged in here is costing me $180 a year to run at the current electricity price, or per quarter if you're paying electricity on a quarterly basis, or per hour if you really want to know per hour what it costs to run. Incidentally, this is a Starlink internet connection is what I'm measuring, so it's quite small. But then it's got energy as well. So it's telling me at the moment that on average per year, my Starlink is using 450 kilowatt hours per year. Yep. So it's quite a significant amount of energy when you add it up over the whole year.
So basically, and do you think that way when you're doing service? Do you want to have actual measurements? You don't want to rely on specifications, on labels all the time?
I do a mix, but there's a few appliances that are very difficult to estimate. Those are things that have cycles like washing machines, refrigerators, dishwashers. Generally, my favorite one to do is the refrigerator. If you plug this in for about half an hour, you'll probably pick up a few cycles of the compressor running, and you can pretty quickly estimate the energy usage on a daily basis from that reading. And I like to pick the refrigerator because it's the one appliance in your house that you never turn off.
Yeah, so it's not difficult to find. As long as you know the cycle, you can estimate the use. Very good. Okay, let's get on to a question that, at least for me, it's a bit tricky, but I don't know what you think. But sometimes you can hear people and they will say solar technology is not as pro-environment as one likes to think, because in the manufacturing procedure, you are using pollution, and you have the cobalt mines, and you have the all of these things. What's your thinking on this topic?
Okay, there's a popular metric called embodied energy in a product, and that means the amount of energy it took to manufacture that product. And if you know what the energy source is that manufactured it, say it might be a coal-fired power station in China that manufactured that product, you can then do an environmental impact assessment on the greenness of that product. But let's take solar panels for an example. Back in the early days of solar, let's talk the 1960s, solar panels had a terrible energy footprint. The amount of energy it took to manufacture them was more than they ever produced in their life. So they actually weren't really renewable energy, but that was in the 1960s. It's amazing oil companies have hung on to that figure and keep bringing it up and saying, look how terrible solar panels are. But since then, solar panels have got very, very efficient to manufacture, and now we're looking at embodied energy in a solar panel being replaced in 1 to 2 years of being put in the sun. So it's definitely a carbon positive outcome. It's not just neutral, it's positive. It's offsetting a lot. But then other products are more tricky. So take batteries, for instance. Lead acid batteries, you might think lead, no, it's dangerous. It's kind of toxic material. But actually lead is the most recycled material on the planet by weight, because it's so valuable and it's so easy to recycle. We just heat it up, melt it, and you've got new lead again. So a lead acid battery actually is a cradle-to-cradle battery. That means at the end of life, they make another one out of it. So that's pretty good from a Green's point of view. That lead isn't being constantly mined. But then when you look at lithium batteries, there is a few issues. So some chemistries use a material called cobalt. And cobalt, unfortunately, comes from areas where there's a lot of conflict, child exploitation, and it is kind of considered the conflict mineral. It's also found in mobile phones and other things. So nickel manganese cobalt lithium ion batteries, gee, that's a mouthful, are a bit of an issue from an environmental, but also from a social point of view. Companies are aware of this now, and there's a strong move to get rid of cobalt from lithium nickel manganese cobalt batteries and replace them with other materials. But one of the most popular chemistries in lithium is lithium ferrophosphate, which it doesn't have those conflict minerals, but it still is lithium. And lithium is a resource scarce material. There's only about 6 mines in the world. Australia has the second biggest one. Peru has the biggest. I think China's number 3. And, at the rate that we're developing electric cars dependent on lithium batteries, we'll probably run out of lithium in, 20, 30 years. And it's not easy to recycle it. So it is a consideration, what will be the future of energy storage. And I think this is also one of your next questions, but there is actually an eruption of alternative technology at the moment. None of them are mature enough to replace lithium-ion batteries, but there are many sort of on the drawing boards or in the test labs right now. So I'm sure we'll get there. So there you go.
Yeah, exactly. That's the next question. Can you be more specific there? Do you have any knowledge to share with us? Do you know anything about research going on that could change the battery technology within the next few years? Or are we looking at more like 5, 10, 15 before we see any significant change?
Well, to make a battery, generally you'll need a metal element. So lithium is one of the metal elements, but so is sodium. And sodium, by contrast, it's not quite as energy dense at the moment as lithium. So you can get sodium-ion batteries, for instance, but it is I think it's the 5th most abundant element on the planet. We're not going to run out of sodium. In fact, the oceans are made up of sodium chloride. Sodium's everywhere. So we may see lithium being replaced with a more sustainable and easy to recycle technology like sodium ion.
So the latest changes, just to freshen up what's going on right now, is that people are moving to LFP, or the manufacturers are moving to LFP, which is cobalt free, and also don't have the thermal runoff as much safer. So at least that's a good development, and it's also moving to high voltage, which increases the efficiency. So we are seeing, even though it might be major development revolutions, we are seeing gradual improvements all the time. So yeah.
Agreed.
Let's go on. Let's take some questions from the members. Yeah, we've been touching on these things. Any other improvements that you think will happen, like within the next 3 to 5 years, either in panel technology or efficiency or something like that?
Well, I've been kind of constantly astounded by panel efficiency and size. The cost curve has been pretty linear down since about 1974, and at the current rate of decline in solar panel pricing, it should be approximately 0 in about 10 years' time, but that'll never happen. So yeah, look, really have to give credit to Professor Martin Green from the University of New South Wales. He probably deserves a Nobel Prize for what he's done to reduce the cost of solar and to produce more efficient solar panels in the same over a period of something like 30 years of research. And many of his students have gone on to found big solar panel companies. He's still a humble professor at a university. So solar has had a wonderful trajectory in terms of improving its efficiency and performance. With battery storage, we're still yet to find those standout winners going forward. We've got a lot of contenders, including things like flow batteries, which like zinc, bromine, flow batteries. We've got sulfur, we've got air earth batteries. There's even solid state batteries that have been developed in the lab. So semiconductor, batteries. So yeah, there's lots of things on the drawing board, but I'm kind of the guy at the end, not the guy in the R&D department, and I like to see the product on the shelf before I get too excited by it.
Exactly. But efficiency of panels seem to have been stuck around 20 though for quite a few years. But you think it will make a move to 30 soon or not?
It depends if we find that there's other materials other than silicon that can be used. So, it's skipped my mind what the name of it is. It's a Russian word because the inventor was Russian. It's got a higher conversion efficiency, around about 30%. Perovskite, that's what I was looking for. And perovskite can be made at low temperature, so it's actually low-cost manufacture, around about 200 degrees Celsius to manufacture it. Can be made from more available materials than highly refined silicon, and efficiencies in the 30s, not the 20s. So that's another possibility of seeing that take off.
And then one question, or many guys, they want to know what kind of inverters, like brands that you recommend. I don't know if you ever give advice about that, or you can say, well, what kind of manufacturer do you like for hybrid? But do you ever give advice like that? Or?
I wish I had $1 for every time someone asked that question, but I do have a very useful answer to that one. I'll tell you in 20 years' time.
Okay. We'll wait for that one. If I can comment on that, I think the problem with answering that is that, number one, it changes all the time. it's so fast. Like I would say one of the brands that I like to work with, Alpha ESS, that I love with the hybrid systems. But there are so many new ones coming. So if you make a recommendation now, yeah, you might be right now, but it might change in 6 months. So that's one reason why it's difficult to talk properly about, you know, what brands are the best and what models are the best, because it is changing so much. And especially, and if you do say one, then people will hold you to that later. That's not what we want. We want to be able to say or give the best recommendation at the specific time based on availability, based on so many factors. It's not only about what is the best, it's about what's available. And that's especially relevant in Thailand because, for example, Tesla is not available in Thailand. It doesn't really matter if Tesla might be the best, who knows? But if you can't get it, then it's irrelevant, you know, so many difficulties like that.
Yeah, I always duck that question because there's no correct answer.
Yeah, exactly. And it depends on another factor, which is very important, is the situation of the client, which is enormously different from person to person. So the recommendation will be completely different based on that exact specific client. Okay, let's move on. Okay, so we had a question regarding rooftop, because obviously in Thailand it's very hot. So we know that the efficiency of panels is reduced when the hotter it gets. So the user was asking, what alternatives do we have to rooftops to sort of reduce that problem?
Actually, tilting the panel is one of the most effective ways of cooling it because you create convection. There's good evidence, and I've actually done some testing here at the lab using thermocouples on the back of the cell and irradiance meters and also measuring the output, that for every, if you move from, say, horizontal, if you've got your panels completely horizontal, the cells will be about 35 degrees hotter than ambient in full sun. And given that you lose about 0.33% per degree above test conditions, which is 25 degrees Celsius, certainly in Thailand, you might be up around 70 degrees on the cell. So you're going to be losing, 35 times 0.33% of your power. So it's quite a lot of power being lost because the panels are horizontal. But just by putting them on an incline of 10 degrees or so, we'll cool them about 5 degrees further. So they'll be maybe about 30 degrees above ambient. And if you can put them on a tilt frame so they're away from the roof, they'll pick up any air movement at all, just the slightest breeze. And the steeper pitch will more accelerate the convection of heat off the back of the panel. And so you get down to about 25 degrees above ambient. So actually you can get sort of 10 degrees of temperature change just by getting off the roof and tilting up.
Okay, so you're talking about the slope difference between the roof and the panel. So let's say you have the slope of the roof here. If you can increase the slope of the panels a little bit, so there's a bigger difference between the panels and the roof slope. That's what you mean?
Yep. You're not trapping hot air underneath the panels.
So if you have them parallel, then even though you have a distance, let's say, I don't know what the standard, because we always have some distance. Obviously, it might be 10, 15 centimeter. But then if you have that, and even if you compare that, let's say we compare 15 centimeter with parallel and 15 centimeter with increased tilt, you will have that difference.
Yeah, well, it does depend so much on the pitch of the roof. I'm talking a flat roof, the worst case, panels flat on a flat roof, inclined roof, say 30 degrees pitch with the panels parallel 150 mils away from the roof. That's kind of a middle condition. That's good because you're getting a thermal chimney effect there. But if you have freestanding panels, they're not actually closely coupled to the roof. They'll get more air movement. So those are ways of cooling a panel. But actually, I wouldn't be too hung up about it. Actually, if the cost of tilting the panels is compared with the cost of just adding more panels, then the fact that you're losing some power is overcome by just adding more panels at the similar cost to adding racking system to get the panels away from the roof.
Yeah, and that's often the conclusion when we talk about all these things. When you have lack of efficiency or you have lack of energy, you just add panels. And that's almost always the best solution because of all these motorized things are too expensive, and also maintenance. But tilting, I like that one because it doesn't have to be expensive. And it doesn't have to be hard. But of course, if you have too much tilt, then you might get too much wind under. So you have to balance out with that.
Well, the panels are rated for different wind pressures, and so are mounting systems. So you need to know what the wind zone that you're in, and then use a system that's appropriate for that. But one of the advantages too for tilting panels away from a roof is if the roof is a light color or you paint it white, you can use bifacial panels to get significantly more power out of those panels. And that would overcome, once again, that loss of efficiency due to heat, because you've actually got more powerful panels. Both the front and the rear are producing energy.
And then a very limiting factor in most cases is obviously roof size. It comes down to the area that you have available. And if your area available is very small, then you might have to go for some more innovative solutions in these terms. While if your area is big, okay, then you just add some panels. You go for a simple solution. So yeah. Let's see. Yeah. Okay. So that was also, that means we covered the bifacial.
Can I just say something else about bifacial? They're not always better than monofacial, because a monofacial panel has a white backsheet, and that white backsheet gives some internal reflection within the cell. Now, if you put bifacial panels on a parallel to a roof without much clearance, just say 100 to 150 mils off the roof, they're effectively reflecting nothing off the roof. There's a dark shadow underneath the panels. So you actually produce less power with bifacials unless you utilize that what's called albedo, the reflected light from the roof.
Yeah, so the bifacial, it basically means that they are best suited for carports and stuff, where you actually have some distance between the panels and whatever is under. So you get that reflective light.
It also means you've got to consider where your supports are. Try to avoid putting the support systems directly under the cell, like maybe where there's the junction boxes, for instance, so that you're not shading with your support system the back of the panels as well.
I think we're okay. I think this is very good. I don't know if you have any comments at the end. I mean, the thing about Thailand is that we don't have access to all the equipment that you have. I've actually, and if we can get it, I have never been able to get bifacial, and I think if I were able to get it, I would have to pay a premium like no other. So once you want specific equipment in Thailand, you have to pay so much more. So that means that, for example, microinverters and stuff like that, we can get it, but the price is so enormous that it doesn't make sense in the end, unfortunately.
Oh, wow. I'm surprised to hear that about the microinverters. It's funny because I've just got off a call. Hold on a second. I'll just grab a prop. Hang on. So yeah, I was being interviewed by this. Well, I was not interviewed. I was talking to a company from China who make multi-input microinverters. Now, maybe I'll just use my overhead camera so you can see this one. So this here has two panels, so you can connect one panel on one side and one panel on the other. They have a daisy chain cable, so not a trunking system like some do. They just have a daisy chain which you plug the AC of one into the AC of the next, etc. And this is their smaller unit. It's what they call it a 2-into-1, and it's rated at what does it say here on the back? 700 VA. But then they've got a bigger one, comes with a handle, and it's 4 into 1. So this one is 1200 VA or 1200 watts. So 4 panels. What this means is you actually reduce cost a lot with the microinverter system when you start having multiple panels into one unit, because they're only manufacturing one box, as it were. So this 1200 watt microinverter, which is quite big really when you think about it, there it is significantly cheaper than 4 single panel microinverters. The sum of 4 single panel microinverters. This company claimed that they're about half the price of the major competitor in Australia because of this combining of multiple inputs into one product.
Well, it is probably an area where there's going to be a lot of development on the microinverters and all that. So I guess it's because some manufacturers have been dominating that quite a lot. So, for example, in Thailand, you don't have that many. Enphase are here. We have Solar Edge. It's pretty much the only 2 that are in that technology that's available where you have proper support in Thailand. I mean, you could import yourself and all that, but then you have other problems with support, and the customer has to wait a very long time if there's a problem and all that. So those are the specific problems that we have to deal with as an installer, that I have to think about how to give the service that I want to the customer. So my thinking so far is that I want to only use products that have actual support in Thailand, that actually have stock here. So I think now we're already finished with the interview, so we don't have to include these things. So now it's just chit chat, I guess.
well, Christian, it's been really great talking to you, and I would love to come to Thailand sometime. So maybe when travel's a bit easier, we might meet face to face.
That would be awesome. And, I have some ideas about how, because I was thinking when we were talking about the lower class and how they're using solar and all these things, like there's such a great opportunity for, if we can get more information out into the population, both only about house building and about solar and maybe other technologies too. Because you have these guys that are able to use it, like they are not rich, they do not have a lot of education, but they have the willingness to go into a technology and try stuff. That's the pure DIY, and because the Thai language is so complicated, I don't know if you ever looked at it, but it is a problem in Thailand that there's not a lot of books on topics, and libraries are not a common thing. And so you have a lot of knowledge that just goes by the verbal. There's no written tradition. Of course, you have a population that understands English, but you actually have that problem with a lot of the population. And so my one idea I had was to have a conference where we could have both international, maybe you, and also some national, and concentrate on how solutions that are cheap and that the population can handle themselves. I think that could create an enormous change for Thai society, because it connects with education too, because when you have the families living in the heat up in Isan and up in the really hot parts, they are not able to, their brains are not functioning properly when it's too hot. And so all these problems, they interconnect. So if you can find cheap ways where the population can solve parts of these problems themselves, you could actually have a huge societal impact.
Indeed. Can I do a shameless plug for my YouTube channel too, which is the Smart Energy Lab, or just Smart Energy Lab. You can translate it into Thai if you use the closed caption option down the bottom there. Press CC. Thanks to YouTube, they do automatic translations. They may not be perfect, but you'll get the gist. But I have a lot of content there, both for the technical side and also more consumer-related information about products. So there you go.
Yeah, so that's great. I mean, I love to see somebody focusing on education and how to get the knowledge out there, because it is so important, and it's all about moving society forward, in my opinion.
Great.
Thanks a lot, Glenn. So we'll end it there, and we can talk on the email how we do it and how we present the videos. And now I have to.